In 1948, a mechanic in Wyoming built a house for his family out of $400 in wheat straw. It has never had a heating bill. It has never had a cooling bill. He is 99 years old and he still lives in it. You cannot build that house in 42 states. Not because anyone was hurt, not because anything failed, because the organization that writes America's building codes earns its operating budget from the $18 billion industry that sells you the alternative. Stay with this until the end, because there is a non-profit in Moab, Utah that found a legal loophole and has used it 47 times since 2009. 47 families now live in straw bale homes they built themselves. Their combined annual heating bill across all 47 households is less than what the average American family pays in a single month. This is the story of the house that heats itself forever, and the building code they wrote to make sure you never build one. The physics of a straw bale wall is not complicated. Straw is the hollow stalk that remains in a field after the grain has been harvested. It is agricultural waste. Farmers either sell it for animal bedding, burn it where that is still permitted, or plough it back into the ground. In states like Kansas, Montana, and North Dakota, it piles up in quantities so large that disposal is itself a logistical problem. The US grain belt produces approximately 200 million tons of straw per year. The fraction used for construction is statistically invisible. When that straw is compressed into a rectangular bale by a mechanical baler, and those bales are stacked into a wall, something happens to the hollow stalks that no conventional insulation manufacturer can replicate at any price. The air inside each straw tube becomes trapped. It cannot circulate. It cannot convect. It sits between the dense packing of thousands of stalks pressed against each other, and it holds. That trapped air is the insulation. The wall achieves it passively, without manufacturing, without chemical treatment, without any process beyond compression and stacking. A standard two-string straw bale measures approximately 18 inches wide. A wall built from those bales, plastered on both sides with lime or clay, achieves a thermal resistance of R30 to R35. That number should stop you. A standard American stick frame wall with fiberglass batting, the wall inside almost every house built in the United States since 1950 is specified as R19. But that R19 figure is for the insulation material alone. The wall assembly is built, accounting for thermal bridging through the wooden studs, the gaps, the inconsistency of batting installation, actually performs at around R14 inches practice. Oak Ridge National Laboratory published that finding in 1998. The test was conducted on a properly constructed straw bale wall system and a properly constructed conventional wall system under identical laboratory conditions. The straw bale wall performed at R30 inches the assembled system, not the material alone, the system. R30 versus R14. The straw bale wall delivers more than twice the insulating performance of the standard American home, but R value is only half of the story. The other half is thermal mass. A plastered straw bale wall is 20 to 27 inches of dense material, straw, lime, clay. That mass absorbs heat slowly during the day and releases it slowly at night. The technical term for this delay between outdoor temperature peak and indoor temperature response is thermal lag. In a well-built straw bale structure, that lag runs 8 to 12 hours. The hottest part of the afternoon never reaches the interior until well after midnight, when the outdoor temperature has already dropped. In winter, the daytime solar heat, stored in the walls, releases into the living space through the coldest hours before dawn. The house manages its own temperature through mass and resistance without asking anything of a boiler, a heat pump, a utility line, or a monthly bill. The Community Rebuilds organization in Moab, Utah, has been monitoring the utility costs of their straw bale homes since 2009. Their executive director, Ricky Epperson, published the results. Homeowners in their program save approximately 85% on monthly utility bills for the life of the home, not for the first year. Not after a performance degradation curve. For the life of the home. That is not a reduction, that is elimination by any practical measure. Two systems together are 35 wall resistance and 1-2 hour thermal lag. Eliminate the heating and cooling bill, not reduce. Eliminate, but stay with that number. Because right now, in 42 states, you cannot get a building permit for a residential structure with walls built this way without spending $5,000 to $25,000 on an alternate method approval process that the issuing agency is not required to grant. The wall that performs better than anything the building code currently mandates is not on the approved list, and we need to talk about who wrote that list. In 1995, the city of Tucson, Arizona, and the state of New Mexico became the first jurisdictions in the United States to pass a formal straw bale building code. That code, developed from fieldwork on structures like William Pester's Nebraska house, established basic prescriptive standards for moisture protection, foundation height, and plaster thickness. It was a functional document. Builders used it, inspectors used it, houses got permitted. Over the next 8 years, exactly 3 US states and 7 cities or counties adopted their own versions. That was it. In a country with 50 states and approximately 3,000 counties, straw bale construction had formal code recognition in 10 jurisdictions. In the remaining 3,129 jurisdictions, a builder who wanted to use straw bales was required to submit under what is called the Alternate Methods and Materials Clause of the International Residential Code. That clause allows a building official to approve a non-standard construction method if the applicant can demonstrate equivalence to code-specified methods in strength, durability, fire resistance, and thermal performance. In theory, this pathway exists. In practice, the cost of demonstrating equivalence engineering reviews, independent laboratory testing, legal documentation, official review fees runs between $5,000 and $25,000 per project. That cost falls entirely on the builder. It must be repeated for every jurisdiction that has not adopted a straw bale code, and the building official retains discretionary authority to deny the application regardless of the evidence submitted. The California Straw Building Association has documented cases where applicants submitted complete engineering packages, independent fire ratings, and peer-reviewed thermal performance data, and were denied on the grounds that the method was not in the code. Not that it was unsafe, not that the evidence was insufficient, simply that it was not in the code. The question that arises is not whether this is an inconvenient process. The question is who benefits from the fact that it exists. But stay with it a moment longer, because in 2013, something happened that should have changed everything. On the 4th of October 2013, at the International Code Council's final action hearings in Atlantic City, New Jersey, a proposed appendix on straw bale construction was approved for inclusion in the 2015 International Residential Code, Appendix S, the result of more than a decade of work by architect Martin Hammer, the California Straw Building Association, the Colorado Straw Bale Association, the Straw Bale Construction Association of New Mexico, and the Ontario Straw Bale Building Coalition. Thousands of volunteer hours, real testing, real data, real code language. The appendix passed. It is now in the National Model Code. Here is what that means in practice. The IRC is the Model Residential Building Code used as the basis for construction law in 49 US states, the District of Columbia, Guam, Puerto Rico, and the US Virgin Islands. Every 3 years, jurisdictions review and adopt updates to the IRC. The appendices in the IRC are optional. They must be explicitly adopted by each jurisdiction to become enforceable. As of 2024, the straw bale appendix, now designated Appendix BJ, has been explicitly adopted by Maryland, New Jersey, and California. 3 states, 47 states have the appendix sitting in the national model code they use as their legal foundation, have chosen not to adopt it, and continue to require the $5,000 to $25,000 alternate method approval process for any builder who wants to use the same material that William Pester's great-great-grandchildren are still living inside of right now. Think about that. Now we need to talk about who wrote the approved list, and it involves $42 billion a year. The International Code Council is a private, non-profit organization headquartered in Washington, D.C. It writes the International Residential Code, the International Building Code, and 9 other model codes that govern construction standards in virtually every US jurisdiction. It is not a government agency. It is not an arm of any federal department. It is a private organization that produces private documents which are then adopted by governments as law. Its voting membership includes trade associations and corporate members from the construction materials industry. Its operating budget is funded in part by licensing fees paid by the same jurisdictions that adopt its codes, and by technical committee participation fees paid by industry representatives. The National Roofing Contractors Association has been an ICC member since 1994. The North American Insulation Manufacturers Association, whose member companies include Owens Corning, Johns Manville, and Knauf Insulation, participates in ICC code development. Owens Corning alone reported $9.7 billion in net sales in 2023. Johns Manville, a Berkshire Hathaway company, operates 44 manufacturing facilities and serves customers in more than 80 countries. The combined US revenue of the major fiberglass and mineral wool insulation manufacturers runs to approximately $18 billion per year. These are not the villains of this story as individuals. The engineers and scientists who work at those companies are not conspirators. The code officials who enforce the IRC in 47 states are not co-conspirators. The system does not require individual bad actors. It requires only that the people who write the approved list are funded by the industries that benefit from the approved list, and that the process of getting onto the approved list costs more than most individual builders can bear. The IRC's primary residential wall section, R302, specifies wood frame construction with approved insulation materials: fiberglass bats, mineral wool, spray foam, the approved list. A straw bale wall that performs at R35 as a system achieves a 2-hour fire rating when plastered and has been standing continuously in Nebraska since 1903 is not on that list unless a jurisdiction has chosen to adopt Appendix BJ. The certification process to get a new material onto the primary approved list, not an optional appendix, but the main body of the code, runs through ICC's formal code development cycle, which operates on a 3-year schedule and requires sustained organisational participation that individual builders, cooperatives, and small advocacy groups cannot maintain year after year without institutional funding. The codes do not keep straw bale off the list because it fails. They keep straw bale off the list because getting onto the list costs money that the insulation industry has and owner builders do not. Now stand inside a straw bale house. It is the second week of January. You are in Moab, Utah. The elevation is 4,026 feet. The overnight low was 14 degrees Fahrenheit. Right now, at 11 inches the morning, the outdoor temperature has reached 22 degrees Fahrenheit. The sky is clear. The wind is coming in from the west at 19 miles per hour. You have just stepped through the front door. The walls are 22 inches thick. The window openings cut through them like tunnels, deep set, with sills wide enough to sit in. The interior plaster is the colour of dry sand. You can see where the builders worked, the clay finish with their hands. There are no perfectly sharp corners in this room. Everything curves slightly, rounds at the edges, yields. You are not cold. You take off your coat. The air does not smell like forced heat. There is no furnace smell, no metallic cycling of a heat pump, no dry forced air static. The air smells faintly of earth, of the plaster itself. You breathe it, and it does not scratch your throat the way winter heated air does in a standard frame house. You press your palm flat against the wall, not your fingertips, your whole palm flat. The plaster is warm, not body temperature warm, warm like a stone in late afternoon sun. The wall has been absorbing the household's normal body heat and solar gain through the south-facing windows for the past week. It is releasing that stored warmth right now into this room at 14 degrees Fahrenheit outside. You look for the thermostat. There is none. You look along the baseboard. Nothing. You check the ceiling for a heat register. Nothing. You walk to the kitchen. No radiator. No visible mechanical heat source. Outside, 22 degrees Fahrenheit. Inside, 69 degrees Fahrenheit. The difference between those two numbers, 47 degrees of separation, is being maintained right now by 22 inches of compressed wheat straw and 2 coats of clay plaster. The material costs for the walls of this house were $400 at the time of construction, sourced from farms within 40 miles of the building site. The question that occurs to you is not how, the question is why. In Leeds, England, 20 homes built with prefabricated straw bale panels by the Lilac Cooperative were monitored for energy consumption for their first 6 months of occupation. The University of Bath published the results. Residents of a 4-bedroom house at Lilac reported a combined annual energy bill, gas and electricity, of £190. Their previous house had cost £1,500 a year in energy, an 87% reduction, repeating year on year. That study has never been cited in a single ICC code update proceeding. In North Kesteven, Lincolnshire, the District Council built straw bale social housing and monitored it for long-term performance. Their published report documented insulation levels twice as effective as traditional construction, with the walls alone providing 3 times the insulation value required by UK building regulations. Councillor Stuart Ogden stated publicly that the houses were designed to last approximately 200 years. That report has never been cited in a single ICC code update proceeding. At Oak Ridge National Laboratory in 1998, researchers Jeffrey Christian and Jan Kosny conducted a hotbox test on a straw bale wall system built according to the Tucson, Arizona Structural Code. It was the most rigorous independent laboratory test of straw bale thermal performance conducted in the United States to that point, commissioned by the Department of Energy's Office of Building Technology. The test results showed that with properly applied interior and exterior plaster eliminating the natural convection gaps between the straw and the wall surfaces, the assembled straw bale wall system achieved an R value, approximately 60% higher than a standard R19 fiberglass batted wood frame wall. That study has never been cited in a single ICC code update proceeding. The BRE Centre for Innovative Construction Materials at the University of Bath spent 10 years testing prefabricated straw bale panels with ModCell, subjecting prototype structures to fire tests, thermal transmittance tests, accelerated weathering tests, acoustic tests, simulated flooding, impact testing, and simulated hurricane force wind loads. The panels passed every test. The university's published conclusion: straw bale buildings reduce energy bills by 90% compared to conventional housing stock. The BM Trada Q-Mark certification was awarded, meaning insurers and mortgage lenders in the UK now treat straw bale homes as insurable and financeable. That certification program has never been cited in a single ICC code update proceeding. France has over 5,000 straw bale buildings. The oldest, the Foyet House in Montargis, was built in 1920 and is still standing, still occupied, still performing. Germany has straw bale structures including multi-unit residential buildings and public schools. Austria, Switzerland, Italy, Belgium, Canada, and Australia all have straw bale construction communities, professional associations, formal training programs, and in several cases, national or regional building code recognition. The European Straw Building Association coordinates technical development and certification across the continent. None of this has been cited in a single ICC update proceeding for the primary body of the IRC. Think about that the next time someone tells you straw bale construction is not up to modern standards. The houses, it is compared unfavourably to have R14 walls. The houses being protected from the approved list have R35 walls. The houses being protected from the approved list were built in 1903 and they are still standing. Here is the crack in the wall. The owner-builder exemption exists in 42 US states. It is not a loophole in the pejorative sense. It is a written provision of state construction law that recognizes a specific category of builder, the individual who constructs a residence for their own personal occupancy and does not sell, lease, or rent it for a defined period after completion. The exemption allows that individual to build without a licensed general contractor, and in many of those states, without full compliance with the standard residential building code, provided the structure is for their sole personal use. The exact terms vary by state. Texas, New Mexico, and Arizona have among the broadest owner-builder provisions in the country. In Texas, an owner-builder constructing a single-family residence on their own land for their own occupancy is not required to hold a residential contractor license. In New Mexico, the owner-builder exemption has been used continuously since the first straw bale code was established in 1995. In Arizona, rural county jurisdictions in particular have permitting processes that accommodate alternative methods under owner-builder provisions with substantially reduced documentation requirements. The states with the most restrictive codes, where the owner-builder exemption is narrowest or most hedged with contractor licensing requirements, include Illinois, Michigan, Indiana, Wisconsin, and most of the urban regulated jurisdictions in the Northeast. These are, not coincidentally, also the states where the Construction Industry Trade Association presence is heaviest and the alternate method approval process is most prohibitive in cost. Community Rebuilds is a 501c3 non-profit organization based in Moab, Utah. Founded in 2009, it operates with funding from the USDA Rural Development Mutual Self-Help Program and builds affordable straw bale homes for low-income residents of Grand County, Utah. The organization trains its clients in the construction process as a condition of the program. The clients provide the sweat equity. Community Rebuilds provides the technical knowledge, the materials, and the legal navigation. Since 2009, Community Rebuilds has completed 47 straw bale homes under Utah's owner-builder provisions. 47 families who earn between $15,000 and $35,000 a year in annual household income now own their homes outright, with no mortgage, built on land they purchased through the program at below market rates. Their executive director has published the energy savings data, approximately 85% reduction in monthly utility costs sustained for the life of the home. You want to see what that looks like in practice? A family with a household income of $28,000 a year, the average American family at that income level spends approximately $2,200 a year on energy, heating, cooling, hot water. In a community rebuild straw bale home, that family's energy cost is approximately $330 a year. The difference is $1,870 annually. Over a 30-year period, that is $56,100 in savings. That stays in the family's hands, rather than going to a utility company 47 times over. Picture the weekend they stack the bales. A Saturday in October, still warm enough to work without gloves. 12 people from the neighbourhood helping. The bales coming off a flatbed truck, stacked like oversized bricks. Running bond, each course pinned with rebar. Children on the site. A grandmother applying the first scratch coat of clay plaster with her palms flat against the wall. A family that owes nothing to anyone. The wall is cracking. Not the straw bale wall that one is doing exactly what it has always done. The regulatory wall. Oregon adopted Appendix BJ in its 2021 code cycle. Washington State has active advocacy campaigns targeting adoption in the current cycle. California adopted its own straw bale appendix, Appendix S, of the California Residential Code years before the National Appendix existed, and continues to refine it through each 3-year code review. Maryland was the first state to formally adopt the National Appendix after its 2015 inclusion, effective the 1st of January 2015. New Jersey followed, effective the 21st of September 2015. That is 5 states with formal straw bale code recognition as of 2024, compared to 3 in 2012. The rate of adoption is slow, it is not zero. The International Straw Bale Building Registry documents straw bale structures in every US state, including the 42 that have not adopted the appendix. The buildings in those states were permitted through the alternate method pathway, through owner-builder exemptions, through rural unincorporated jurisdictions where enforcement is limited, through persistent advocacy by individual builders who understood that the burden of proof was placed on them by a system that benefits from them failing to meet it. Each permitted straw bale structure creates a precedent in its jurisdiction. Each building inspector who reviews and approves a straw bale project becomes familiar with the material and the performance data. The Ecological Building Network, the California Straw Building Association, and the Development Center for Appropriate Technology have jointly maintained a body of publicly available technical documentation, fire test results, thermal performance studies, structural engineering calculations, moisture monitoring data specifically to reduce the cost and friction of the alternate method approval process. The physics has never changed. An R35 wall built from a waste material that costs $3 per bale at harvest performs better than an R14 wall built from a manufactured material that costs $42 billion worth of manufacturing capacity to produce. That fact does not become less true when it is excluded from an appendix. It does not become less true when the permitting process costs $15,000. It does not become less true when the building inspector has never seen one before. The demand has never gone away. The only thing standing between straw bale construction and the American mainstream is Appendix BJ optional in 47 states, written into a national model code by a private organization funded by the industries it benefits. Updated every 3 years without modification to its primary wall sections, while the straw bale homes it restricts keep standing and the utility bills it protects keep rising. William Pester's house in the Nebraska Sandhills has been occupied continuously since 1903. 122 years, 0 utility bills, $11 in materials at time of construction. The code that excludes it was written in 2000. There is one more thing you need to know. Straw bale is not the only material on this list. Around the year 1000, the Pueblo people in the high desert of what is now New Mexico built a house from river clay, sand and straw. The walls were 2 feet thick. The material cost in today's money was approximately $300. That building is still occupied. A woman named Simone Swan has built 600 homes from the same material on the Texas-Mexico border for families earning $8,000 a year. It is illegal to build this way in 47 states. Not because it failed, because the Portland Cement Association generates $18 billion a year, and a wall made of free river clay does not require a single bag of Portland cement. That story is on your screen right now. Click it.